What happens to nuclear waste? Nuclear power plants generate waste while generating energy, but what that waste is and how it's managed are not the same as you think. Hey guys, welcome to our YouTube channel. Before we go on with this video, don't forget to subscribe to our YouTube channel. Kindly click on the notification bell to get updates on our exciting content. Nuclear reactors generate a limited quantity of waste managed responsibly from the beginning of civil nuclear power. Several management options, such as direct disposal or reuse in reactors to generate more low-carbon power, are used. When most people think of nuclear waste, they're thinking of fuel previously used in the reactor. Today, we'll reveal what happens to nuclear waste. But before we delve in, let's understand what nuclear waste is and where it comes from. What is nuclear waste, and what are we supposed to do with it? Radioactive or nuclear waste is a byproduct of nuclear reactors, fuel processing plants, hospitals, and research facilities. It comes from these places. Radioactive waste is also made when nuclear reactors and other nuclear facilities are decommissioned and dismantled, and this waste is also radioactive. Like all industries and energy-producing technologies, nuclear energy has some waste products that have to be cleaned up after they're used. There are three types of nuclear waste: low, intermediate, and high level. They're all based on how radioactive they are. 90% of the waste comprises items that aren't very radioactive, like tools and work clothes. Only 1% of the total radioactivity is in the waste. On the other hand, high-level waste only makes up 3% of the total volume of waste. Still, it has 95% of the total radioactivity. This is because it mostly consists of used nuclear fuel that has been designated as waste from nuclear reactions. What are high-level nuclear wastes? Wastes that have been used in a nuclear reactor and is no longer good at making electricity is called high-level radioactive waste. Spent fuel is both hot and radioactive, so it needs to be handled far away and protected. Ceramic pellets of uranium-235 are inside metal rods that make up nuclear reactor fuel. This means that before these fuel rods are used, they are only a little radioactive, so they can be handled without special protective gear. Urea breaks down into two parts during the fission process. In the beginning, uranium atoms split, which releases energy that can be used to make electricity. The fission makes radioactive isotopes of lighter elements like cesium-137 and strontium-90, which are both radioactive. In high-level waste, there are a lot of isotopes called fission products. They make up most of the heat and radiation. Second, some uranium atoms take in neutrons that are made during fission. These atoms make heavier elements like plutonium, which can be used to make bombs. Some of the heavier elements, or transuranic, don't produce nearly as much heat or radiation as fission products do. They also take a long time to decay. It takes 1,000 years for most of the radioactive hazards in high-level waste to go away. Transuranic wastes, which are also called TRU, make up the majority of this. Radioactive isotopes eventually break down or decompose into harmless materials. Some isotopes can take hours or even minutes to die, but other isotopes die very slowly. They both have half-lives of about 30 years. Half the radioactivity will decay in 30 years. In 24,000 years, plutonium-239 has a half-life of about the same length as its full life. High-level wastes are dangerous because they can cause fatal radiation doses when people are exposed to them for short periods. After 10 years, a typical spent fuel assembly has a surface dose rate of more than 10,000 rems per hour, far more than the 500 rems humans need to die all at once. High-level wastes could make their way into groundwater or rivers, getting into food chains. It would be a lot easier to get this dose through indirect exposure than through direct exposure. Still, a lot more people would be exposed. There is still some uranium and plutonium in the fission products after reprocessing. This separates them from the other materials that came from the fission. They can be utilized again as fuel. Most of the high-level waste other than spent fuel that has been generated in the last 35 years comes from reprocessing fuel from government-owned reactors. These reactors make plutonium from naval, research, and test reactors. In the 1960s and early 1970s, a small amount of high-level liquid waste was made when commercial power reactor fuel was reprocessed for use in power plants. There is currently no commercial reprocessing of nuclear power fuel in the United States. Most of the high-level commercial waste still around is made from unprocessed spent fuel used in nuclear power plants. The NRC makes sure that all commercially generated radioactive waste is stored and disposed of in the United States. This includes high-level wastes made by the Department of Energy that is kept for a long time and not used for research or development. The NRC also looks after these wastes. Regulations set minimum standards for how licensees must manage wastes, but they also allow for a wide range of technological approaches. So, where does the nuclear waste go? The nuclear industry is different from any other energy source because it takes full responsibility for all of its waste. Many permanent facilities for low and intermediate level waste are in use. Facilities for high level waste and used nuclear fuel are being put into place, and new facilities are being built. Since nuclear fuel is very energy dense, it takes very little of it to make a lot of electricity, particularly when compared to other types of energy. As a result, only a small amount of waste is made. A brick-sized amount of waste would come from a reactor that could power a person for a year. It only weighs approximately about the same as a sheet of paper. Only 5 grams of this is high-level waste. In a typical 1,000 megawatt nuclear power plant, which could power more than 1 million people, only 3 cubic meters of vitrified high-level waste are made each year. If the used fuel is recycled, that's only 3 cubic meters. There are also about 300,000 tons of ash and 6 million tons of carbon dioxide made by coal-fired power plants that generate 1,000 megawatts of electricity a year. Most of the material in used nuclear fuel can be reused, even though some countries, like the United States, treat it as waste. Almost all of it could be used as fuel in some type of reactors. Uranium makes up about 97% of it. Plutonium and uranium are 2 elements that can be reused in conventional reactors. Recycling has so far been mostly focused on getting these elements out of old nuclear waste. This separated plutonium and uranium can then be mixed with new uranium and used to make new fuel rods. As you can see, many countries have used plutonium recycling to make electricity while also reducing the radiological footprint of their waste. Some of the byproducts, about 4%, mostly the fission products, will still need to be disposed of in a repository. They are immobilized by mixing them with glass, which is called vitrification. Are nuclear wastes harmful to health? In fact, nuclear waste has never done anything bad to people since the beginning of the civil nuclear power industry. People think that because some parts of nuclear waste remain radioactive for billions of years, the threat must be kept up for that long. It's not true. It will be radioactive for a few 100,000 years, but the radioactivity from the main part of the waste that could cause health problems will be down to safe levels in a few hundred years. One reason nuclear waste repositories don't pose a health risk is that the number of materials that would be found in the environment in the event of a leak would be very small. People who live in the future won't notice any difference in the number of radioactive materials that enter the environment. Because we live in a radioactive environment, as well as inside our bodies, we need to be careful. There is a lot of radiation on Earth, but the quantities from a nuclear waste depository would be almost 50 times trimmer than the average radiation. Life has evolved and thrived in this environment. How are nuclear wastes stored? All of the nuclear power plants in the United States store spent nuclear fuel in spent fuel pools. Reinforced concrete makes up the walls of these pools, which are several feet thick and have steel lines inside. In most cases, the water is about 40 feet deep. It shields the radiation and keeps things like the rods from getting too hot. People use dry casks to store older spent fuel when the pools run out. These casks are stainless steel canisters that are inside the concrete. The fuel usually cools in the pool for at least 5 years before it is moved to a cask. About 10 years is how long the industry usually waits to move things. The NRC has allowed things to be moved as soon as 3 years. The NRC makes sure that cask designs are safe and that dry cask storage facilities can be used for up to 40 years. It's possible to keep your certifications and licenses. The NRC thinks that the spent fuel pools and dry casks both protect public health and the environment. There's no reason to move fuel from the pool to the cask earlier for safety or security reasons. Spent fuel storage at power plant sites is temporary, with the goal of long-term disposal in mind. There are 2 applications for consolidated interim storage facilities in Texas and New Mexico that the NRC is looking at right now. People who work at commercial nuclear power plants would put their spent fuel in these facilities until a permanent place to store it could be found. At this time, there are no permanent places to store high-level waste. That's it on what happens to nuclear waste. If you enjoyed this video, then go on and like it. Please kindly subscribe to our channel and click on the bell button for more of our updates.